Ecovap was set up in 2006 as a result of a partnership between three engineering companies: Toyo Engineering Corporation, Construtora OAS, and Setal Óleo e Gás. Ecovap participated in the modernization project for the Henrique Lage Refinery in São José dos Campos, São Paulo, on the basis of an EPC contract, which included engineering, procurement, construction, pre-commissioning, commissioning support, and for the operation startup, all related to the building of 8 new units. The construction and assembly process of the units was extremely complex, but was carried out by the Ecovap team with high levels of competence, persistence, and commitment. The units were crude coker, coker naphtha hydrotreatment, sulfur recovery, 2 identical units, tail gas treatment, sulfur storage yard, DEA storage area, and interconnections. Ecovap used cutting-edge technology in the form of the most modern software for engineering development, and through the use of a virtual reality room, which allowed the company to make essential adjustments to plans even before construction began. PDMS was one of the main software used in the detailed planning of the project, including blueprints for piping systems, isometrics, and spools for the manufacturing of piping. Through the use of sophisticated infrastructure for engineering and materials on the building site, work commenced only 5 months after the issuing of the initial service order. The ability to make decisions rapidly and to take innovative and successful measures to get things done are major features of Ecovap's dynamic approach. The strategic decision to procure essential raw materials with a long time lag for delivery, even before confirmation had been received from manufacturers of vitally important equipment, was another reason for the successful termination of the project undertaken by Toyo, OAS, and Setal. The resources used in the enterprise were 87% Brazilian as a result of the commitment to national economic development demonstrated by Brazilian equipment manufacturers and suppliers of raw materials, particularly in their use of the Brazilian labor force. 576 items of equipment were procured for the project, including heaters, compressors, air coolers, heat exchangers, pumps, reactors, tanks, towers, and a pelleting machine. Most of these items were manufactured in Brazil, while some were imported from Italy, Japan, the United States, and Canada. The following statistics give an idea of the size and scope of the project. A constructed area of 83,748 square meters, 5,000 tons of building steel, 60,000 cubic meters of concrete, 5,000 tons of metal structures, 576 pieces of equipment, 6,000 tons of piping, 1,000 kilometers of electrical and instrument cables, over 7,000 instruments, a pipe shop with an area of 5,000 square meters and 3 manufacturing lines, a building site with a total constructed area of approximately 28,500 square meters, 3 restaurants with seating for 1,600 people, a fleet of 89 buses and 50 other vehicles, a workforce of 6,000 at the project's peak, and a total of over 31 million man-hours worked during the project. Ecovap considers its 6,000-strong workforce to be its major asset because the capacity of a corporation is measured by its human capital. This firm belief in the prime importance of human relations was the stimulus for Ecovap's investment in over 1 million man-hours of training, specialization, the general education of both young people and adults, and in-house education and motivational campaigns, all of which reflect the company's commitment to a policy of social responsibility. As a result of this policy, Ecovap has always striven for continual improvement in its various processes and has gained international certification in the form of the ISO 9001, ISO 14001, OH/SAS 18001, and SA 8000 diplomas. Ecovap is also proud of the fact that it reached a total of 7 million man-hours worked without any industrial accidents requiring leave of absence. Ecovap believes firmly in human potential and invests in its workforce in order to enhance their social development. This is the essence of Ecovap's mission. When we refer to the scope of the Ecovap project, both the numbers involved and their corresponding challenges can only be expressed with superlatives. The 8 new units produced by Ecovap using an EPC system are highly complex and technically detailed. The successful formula developed to overcome these challenges benefited from the added values provided by Toyo, OAS, and Setal, Ecovap's partner companies, which are excellence, commitment, persistence, responsibility, and competence. There was an unceasing search for different ways of overcoming the obstacles created by the complexity of the project. Most of all, in the crude coker unit, the largest and one of the most important units in the modernization process. For example, the logistical solution encountered for the transportation of the reactors and the fractioning tower was to divide the larger items of equipment into smaller parts. This involved upgrading planning and assembly processes. In an area of 90,000 square meters and with a processing capacity of 5,000 cubic meters of vacuum residue per day, a variety of products such as butane gas, coke, and naphtha are obtained through this production process. The coker naphtha hydrotreatment unit was also the result of a great deal of hard work, which included the assembly of the heater, the reactors, and the compressors. During this process, naphtha is treated with sulfur, which is later recovered. This unit has a processing capacity of 3,000 cubic meters of naphtha per day. The recovery of sulfur is undertaken by 2 identical units, each of which is able to treat 85 tons of acid gases per day. The final product of these units is liquid sulfur, which is then transferred to the pelleting unit. The tail gas treatment unit is unique and is able to process recoverable sulfur from both units at a normal rate of 170 tons per day. The construction of the sulfur storage yard also involved overcoming a number of challenges, one of which was to build the new unit in the same location as the existing one while the latter was still in use. The new unit was completed in July 2009 and has a production capacity of 140 tons per day, transforming sulfur into pellets, which are placed in storage before being transported to the various industrial plants which use them. Unit 311 is of paramount importance to the enterprise, since it is responsible for the interface between all the units involved in the modernization project. Unit 603 was one of the first units in the modernization project to be completed. It consists of 3 storage tanks for DEA, a substance which is used in the gas treatment systems. On October 18, 2010, the crude coker unit was officially opened by the President of Brazil, Luiz Inácio Lula da Silva. This ceremony celebrated years of overcoming challenges, achieving goals, and building success.